Some time ago, I built a pinball cabinet that was simply a wooden frame housing a digital controller board with buttons and a screen. It was great fun, but it lacked two things. One, flexibility, because it had to stand next to a PC, which meant a lot of cables and space, and two, adjustable shots for skill shots due to the lack of analog controls. I bought a new controller kit from Amazon that uses the same button cable plugs and also supports analog sticks for adjusting the strength of the plunger. It's necessary for skill shots on various tables and a must-have for competitive online tournaments. I'll link the kit and other items used in this video in the description below. Before installing the kit, I tested it by simply rewiring the buttons and connecting the thumbsticks. As the PC was already set up for the old pinball controller, this was easy to achieve. I measured the size of the hole saw for the sticks, but somehow ended up drilling with the wrong diameter. So I simply mounted both hole saws and used the scrap wood from the first drill as a guidance. This wasn't a perfect but a quick and functional solution. After drilling and cleaning up the hole, I tested again, and the hole was now big enough for free movement of the thumbstick. Yay! But this build was all about flexibility, so I decided to use some older hardware and build a PC into the cabinet. First I planned to use an ATX board, but switched later on to an ITX board because of limited space inside the cabinet. The hardware is nothing fancy. An i7 3770K with a GTX 1070, an SSD and a 750 watt power supply. Nothing high-end, but okay for pinball effects in full HD, and I can upgrade later on with any other ITX platform. While not being the most demanding hardware, a better ventilation system will be necessary when the PC is housed inside the cabinet. I drilled the holes for the 80mm intake fans as well as for the 120mm exhaust fan. I used the hole saw with 76 diameter for the 80mm fans and one with 127 diameter for the 120mm fan. These two were the best fitting ones from my set. Next was to level the fans and the mounting holes, as I will use a fan grid and it should be aligned with the bottom edge for a clean look. I used the fan itself for marking the drilling points, drilled holes and mounted the fans with M4 screws and nuts. Talking about the fan grills, I downloaded models from Thingiverse and the prints came out very clean. I do strongly suggest grills as a protection, as the buttons are on the side too, and otherwise it's only a matter of time that someone sticks his finger into the fan. They mount together with the fans with M4 screws. All three fans were mounted on the inside of the cabinet. The smaller fans sucking fresh air from the outside and the larger fan pushing the warm air to the rear side, so there will be no heat accumulation. Next thing to do was to get 3D printable mounts for all parts. I went over to Thingiverse and downloaded a simplistic ATX motherboard mount and cut it down in Tinkercad to ITX size, and also re-uploaded it to Thingiverse as a remix. It has been downloaded in the meanwhile a couple of times. I also downloaded a mount bracket for 2.5-inch drives and an ATX sized power supply. All STL files are linked in the description below. Now it was time to arrange all the parts. I used an old IKEA Billy board as a base and it was pretty stiff and would not bend. The next thing to do was to mount everything in place. I will fast forward the process as it took quite a while. If you miss any information or details, just drop me a comment. First I marked all holes and drilled them. I am simply fixing the mounts with wood screws. The motherboard will be oriented in a way that the connectors are facing backwards, so that USB and audio cables as well as HDMI cables of the graphics card can be connected relatively easy. By doing this, also the tower cooler of the CPU is blowing backwards in direction of the exhaust fan. The power supply also exhausts air to its rear. These factors have to be taken into consideration when creating a most efficient airflow. Next were the power cables from the power supply to the main board and the SSD, as well as the SATA cable from the main board to the SSD. I used an old 250 GB SSD from Samsung that I bought a couple of years ago when 250 GB still were a thing. But for Windows, Steam and pinball games it's more than enough. As the SSD, including its mount, isn't high, I mounted it in the front side of the cabinet. I used zip ties to fight the beginning chaos of cables, but the sleek cable management is something different. But hey, if you ever took a look into a real pinball machine, it's absolute cable mess, so it's kinda fit the build. When mounting the graphics card, I realized that I need a bracket or something similar to stabilize it, as it sat pretty wobbly in the PCI slot and would probably damage it by the weight of the card. So Tinkercad, here I come. First I did a design of a ring that surrounds the thumbsticks so that the rough edges of the wood are not visible. It's a simple ring that goes into the saw hole and is surrounded by a flattened ring. Afterwards I did the design for the bracket for the graphics card. A clumsy block, but doing its job. The trick is to provide support while not restricting the airflow of the fans of the GTX 1070. The rings looked pretty nice and fitted well. Later on I did a second iteration with a thinner wall so that the stick had more freedom of movement inside the hole. After that I routed the controller's USB cable and screwed the controller board into place. Please note the awkward angle that is simply due to the cables being a bit short while the button ports on the board being partially on the opposite side of the board. I didn't want to buy cable extensions, so I simply mounted it that way that fitted. The intake fans were connected with a Y cable to the main board's fan header, so they are controllable. The exhaust fan is connected via USB to 3-pin connector. For full speed, a Molex to 3-pin connector could be used on the power supply as well as another wire splitter for the mainboard's header, because mine only has one header. Very important and comfortable, a USB extension cable for hot plug-in Wi-Fi stick or a USB stick, without the need to open up the cabinet. The clip for the GTX 1070 did its job too. It was simply put on the card and screwed into the side panel of the cabinet. Finally, the power cables from the power supply to the graphics card were connected. Like most more powerful graphic cards, this one draws more power than the PCE slot can provide. In the building process, I recognized that I could not turn on the PC on the inside, so I ordered a power button from Amazon. I drilled a fitting hole with a hole saw and printed a smaller version of the ring for surrounding the button. The power button pins are connected to the mainboard's front header, namely power switch plus, power switch minus, power LED plus, and power LED minus. Look up the correct pin locations for your mainboard in the handbook, as this is not necessarily standardized. The button didn't come with any scheme, but I found that it was a picture on the product site on Amazon. Now it was time for a first test, if everything was wired up the correct way. And it was. I could boot from the Windows installation medium into the installation process. I've also added a dongle of a wireless keyboard with a touchpad, which makes things easier to access, especially once the cabinet is closed. As I had everything booted, I used the opportunity to install Windows 10 in this case, as the old hardware is not supported by Windows 11. Next was Steam and the download of a bunch of pinball games. You don't have to download all new. Steam has a built-in option to export and import games or, like in my case, copy the data from another PC in the same network with the same games installed and Steam running. This was fast and convenient. I tested the controls in Steam under the Steam settings and the controller tab, and everything was recognized as it should, even the thumbsticks. I put the screen into the cabinet and changed the orientation in Windows, and of course I turned it the wrong way first. The soundbar was the most easiest thing to install, just clamp it onto the cabinet and plug in the USB cable.
What is it that makes a great soldier? Is it his brain? Or his heart?
When mounting the sticks, I ran into a problem. The mounting holes were too close to the hole in the cabinet's front, as normally the sticks are mounted to the back side and not to the front side. Once again, I went to Tinkercad and designed a plate that holds the thumbstick in place with little knobs that fit into the PCB's hole and little wings that provides more distant mounting holes for screwing it onto the cabinet. Up to now, the cabinet was only used as a screen and controller combination, so it didn't need all of the buttons a normal controller has. I used the hole saw in a slightly smaller diameter than the buttons and the file to match the exact size. With buttons that are screwed with a nut into place, the tolerances can be wider, but again, I'm using what I have. I added X, Y and select in Xbox terminology and an extra button that has a special function on the use controller board because it switches the modes on the controller that the controller is in. After booting Windows, one time pressing this button is necessary for the controller to work properly, otherwise it's not recognized. That's not a deal breaker, but good to know. I decided to use another color for this button so that its different functionality is obvious. I don't want to hide the mistakes I made, because doing means learning. I had to install an additional wooden strip so that the screen sits flat in the cabinet. I took the frame in consideration, but not the curvature of the backside of the monitor that interferes with the height of the GPU and the power supply. Luckily, these strips provided enough clearance. The next thing was the installation of another piece of genius software, fan control. As my mainboard has very limited possibilities for fan management, I use this software to control our fans so that they are quiet and only ramp up when needed. The software also detects the minimum starting speed in RPM, so I set up some fan curves and this can be linked to any temperature sensor in the PC. I use fan control on my gaming rig too and I love it. Setting up the controller was pretty straightforward. Head to Steam, Settings, Controller and select the setup device inputs. Now go through the controls and press the buttons you want to be assigned with the virtual gamepad buttons. Note, I skipped the home and the small button underneath as I don't need them and I don't want to install them. Just press and hold the button assigned with X to skip them. Afterwards, check the game-specific controller settings. If the correct controller is selected, add if Steam Input Controller is enabled. As the backglass pictures do not come with the game, you have to download them separately. I will link the source, I got them in the description. In Steam, browse the local game files and copy the extracted files into the mod and cabinet folder. Afterwards, edit the settings and enable backglass, dot matrix and the cabinet mode. The position and size can be set here too, or also can be set up in the game directly with the advantage that changes can be seen immediately. This is what I show next. For that, head to the settings in Pinball FX. Changes on the dot matrix and the backglass are visible immediately. Also note that the settings have to correlate with your video resolution settings in the game directly, not Windows. In my case, 1200 pixel, not 1080p. When everything is set up correctly, The backglass shows the correct image for each pinball. If you want to swap them out with your own images, just use a file of the same resolution and name it like the downloaded one. And now it is time to play some pinball for a real-world test. I really like how precise and snappy the controls are. For that, be sure to achieve a high frame rate by setting the video settings independent of your hardware. In my case, I try to match my monitor's frame rate, which is 144 Hz, so even if frame drops occur, the game will still be pretty smooth. The more pictures that are drawn, the more ball positions are visible for precise timing of the shots. In my opinion, a screen with a refresh rate over 100 Hz is sufficient to have a good experience, but the more, the better. 60 Hz screens make no sense in my opinion. And use a screen with a good visibility from all angles, preferably an IPS or an OLED panel instead of an VA or TN panel. G-Sync and FreeSync are always preferable over V-Sync. As my Acer Predator screen has G-Sync and I'm using a GTX 1070, I disabled V-Sync completely. I am happy with the performance, although I had to set Pinball FX to Full HD on my 1440p screen. But Pinball FX is one of the most demanding games, other as Pinball FX3 or FX2 or Pinball Deluxe Reloaded, which will run in 2K without problems at highest settings. I added some older hardware on my watchlist as a Ryzen 3600 paired with a 3060 Ti would be absolutely enough for much better optics and frame rates, but keep in mind that I reused some 10-year-old hardware that was just lying around for free. But what do you think about my pinball cabinet? Are you going to build one too? Let me know in the comments below. In any case, stay safe and have fun making.